Hi guys, today we'll be looking at vectors and proving that a line is straight. So let's get cracking. So first thing to do is read the question, and you can see in this question we have been given a point such that OC to CA is 4:1. So they're saying there's a point here called C, and it is that point that point forms a line with the points M and D that we're hypothesizing that we need to show is straight. Yeah, so the principle of this is pretty straightforward. So to prove a straight line, we need to, no, I can't, that's really bugging me. So to prove a straight line, we need to show that either CM is a multiple of or factor of MD, or CM is a factor of CD, or MD is a factor of CD. That is it. So a factor or multiple, so there should be a constant that multiplies all of them. Yeah, and that's what we need to show that. So we need to figure out the vectors CM and then MD, or CD and CM, one of those two pairs, and show that it's a multiple of the other one. So I'm going to first figure out CM. So to figure out CM, I need AB. Yeah, because we can see that CM is CA plus AM. So first let's figure out AB. And AB is negative 5A plus 3B. So we have negative 5A plus 3B. And therefore, AM is going to be half of that, because M is the midpoint. So we have half of what I've just written there. So let's put 3B minus 5A. Looks a bit neater. And so now, obviously, since OA is 5A, OC is 1/5 of it. Yes, so because of this ratio 1:4, that is 4/5. That is 1/5 because there are 5 parts. So OC must be 4A. Dun, dun, which means CA is just A. So now we're in a position to figure out what we needed to, CM. So CM is CA plus AM, which we can now just use the working that we have, which is A plus half 3B minus 5A. So if I multiply that out, that is minus 5/2A plus 3/2B. And so we have 1A minus 2.5 is minus 1.5. So minus 1.5A plus 1.5B. So CM. Now I want to just neaten this up so it makes it easy to see what a factor is at the end. So we can see there's a common factor of 3/2. So CM is 3 over 2 B minus A. And that is very important. So what we'll expect to see now is whether I find MD or CD, that they will simply be a multiple of B minus A. And that's what we need to show that it is a straight line. So if we find MD is, I'm changing color there. MD is that and that. So I need to read the question again to figure out what BD is. So we can see OB to OD is 3 to 4. So OB is 3, OD is 4. So that must be 1B. Yes, you need to make sure you read that bit correctly. So OD is a third extra and a third of 3B is 1B. So the total distance is 4B, therefore BD is 1B. So now we know that, we can figure out MD. So MD is a half of AB plus BD. I'd always advise you to write it out like this if you're working an exam, because it makes your work easy to mark and less error prone. So you get the double whammy there. Half of AB is obviously the same as AM. So we're going to have 3 over 2B, 3 over 2B minus 5 over 2A plus BD, and BD was 1B. So now we have 3 over 2B plus 1B. So 1.5 plus 1 is, you got it, 2.5. So we have 5 over 2B minus 5 over 2A, which will then factorize to 5 over 2B minus A, which is what we were hoping for. So I've got a note from my sponsor there that's getting in the way. So therefore MD is 5 over 2B minus A. Well, look, we can see here these two things are both multiples of B minus A, and they have a common point in M. So since CM and MD are multiples, are both multiples of B minus A, and they have a point in common, they must form a straight line. They are a straight line, and we can also say colinear. Writing colinear. Makes sense? Yeah, it looks a real mess once you've finished, but the process was show that two parts of the line are multiples of one another. Yeah, so let's practice that again and do another example. So let's read this one. This time we have the parallelogram, and it's been labelled in places. And D is the point on C such that OD to DC is 2 to 1. So OD to So that's 3 parts. So this must be 2/3. That must be 1/3. E is the midpoint of BC. Show AD and E are on the same straight line. So in other words, we need to show that ADE is collinear. Yes, first we would want to find AD and we want to find AE. Yes, I'm going to do it a different way this time. Instead of finding AD and DE, let's show that AD is a multiple of AE. Yes, so AD is a multiple of AE. So let's find doesn't matter which way around, AE, AD, it's all the same. Because either way, we're going to have to find BC. So let's find BC first. BC is simply, is parallel to OA, so that must be 2A as well. If BC is 2A, it would follow that BE equals EC, and that will equal 1A. Yeah, so if I'm going from A to E, I want AC plus CE. So AC must be 2B because it's parallel to OB. Yes, I think that should enable us to start. So AE, vector AE is equal to AC plus CE. And AC is 2B. And C is the negative, CE is the negative of EC. Because it's going against the arrow. Yeah, so AE is 2B minus A. So now we need to find AD and show that it is a factor of this, yeah? So if we're finding AD, we can notice AD, the vector AD, is AO plus OD. So we have AO plus OD. Yeah, now OD was 2/3 of OC. That's one thing I haven't figured out. So we need to figure out OC. So I'll do that over here. OC is simply OB plus BC, which is 2B plus 2O. Therefore, OD must be 2/3 of that. Yeah? So, what am I going to write? So that's OC. That's the key one we needed. I'm going to write up here. So we have OD equals 2/3 of OC, which equals 2/3 of 2B plus 2A. Which is 4/3 A plus B. Or B plus A, it's all the same thing. And that is OD. Dun, dun, dun. So AD is AO, which is negative 2A, plus OD, which we've just found, which is 4/3 A plus 4/3 B. Yeah, so we've got 4/3 B plus whatever 4/3, 1 1/3 take away 2 is minus 2/3. So I just need to neaten that up to show that it's hopefully it's a multiple of 2B minus A. So if I look closer, I'll rewrite what we have. 4/3 B minus 2/3 A. Well, there's a common factor of 2/3 there. Yeah, that equals 2/3 of, I can see it straight away, but I'm going to just do it step by step in case you don't see it. Let's take the third out first. We've got 4B minus 2A. And then you can see, additionally, there's another factor of 2. So we can see AD is a multiple of 2B minus A. So since these two vectors are multiples of the same thing, yeah, they are collinear. Yeah, so therefore, since AD equals K is a multiple of AE, i.e. K equals 2/3, they are collinear. Let's do one more for luck, I reckon. Probably this video is a bit long, but I think people that watch it will be keen. So you could always stop playing it now. Dun, dun, dun. Hey, maybe I should have read the question before I said that, eh? So C is a point on OA such that OC to CA is 4/1. I'll change link. So OC to CA. So there's a point here. It's 4/1. D is the point such that AD. I don't think we've done this one, but I'll check in a second. So that must be 4A. And that one's 1A. And that's C. D's point such that AD to DB is 1 to 2. No, we haven't done this one. So AD to DB is 1/3 to 2/3. The line OB is extended to point E. Given that CD is on the straight line, find BE. Oh, this is harder. Really sort of panic in my face there. So let's find CD first. CD equals CA vector CD equals CA plus AD, which is 1A plus 1/3 of AB. which equals A plus a third of, and you can see AB is minus 5A plus 2B. Yeah, I've skipped a step there because I wasn't going to run out of space to write anything. So that will be AB, so minus 5A plus 2B. So let's neaten that up. So we've got A minus 5 over 3A plus 2 over 3B. So CD equals 1 minus 1 2/3 is minus 2/3. So we've got 2/3 B minus 2/3 A. So it's 2/3 of B minus A. Yep, so this time it's telling us that we know it is straight and we just want to figure out this. So we're going to have a result in terms of, if we call that X or K, whatever we want to call it, and we can use that relationship to balance off the answer. So we can either figure out AE or, hold on, CDE. So we can either figure out CE or DE. I'm going to go DE. So DE is 2/3 of AB plus BE. Yeah, so that is 2/3 of minus 5A plus 2B plus X amount of A and B, yeah? So, because we don't know what that is, so let's just call it plus BE. So we have 10 minus 10 over 3A plus 4 over 3B. Yeah, so we know, look, if it's BE is a horizontal line, it will not have an A component. Yeah, so this must be equal to 0A plus, and let's call it KB. So plus KB, okay, looks like a B. Yeah, and then let's simplify that. So I have, no, let's not simplify it. So what I have there is something that has to be in that ratio. Yeah, so this has to be equal to be in a ratio B minus A. So whatever the B number is will be the negative of whatever the A coefficient is. Yeah, and we have the coefficient for A. If I rewrite this, maybe I'm butchering the explanation, but it's what it is. 4 over 3 plus K, yeah, B, minus 10 over 3, A. So if we look, we have a 1-to-1 ratio here, but one is the negative of the other. So this has to add up to 10 over 3. Yeah, because that is 10 over 3. So therefore, K has to equal 6 over 3. Since 4 over 3 plus 6 over 3 is 10 over 3. So K equals 2, because 6 divided by 3 is 2. And it's the B component. So given that CD and E are on a straight line, find BE. Therefore, BE is 2B. So that was 3 examples. I hope that made sense. Talking about lines being collinear, main thing being you need to show that parts of the line are multiples of each other. And if you do that, then you've answered the question. I've been Mr. Raz. Hope you enjoyed my video. See you soon.